Hi guys, today we are here at Central Diesel and we have a little project being done on our pickup, and I would like you to meet Sir Jason Arellano. He's going to be answering some questions that we have. So how long has this place been in business?
This was started by my parents back in July 1978.
Why did they start it? Was there like a purpose for it?
My dad was a equipment manager in a construction company. Then my dad saw that it was a good line of business to enter because he was seeing a lot of diesel calibration being done during that time. So he decided to start this company by telling my mom to start it first, like just doing small projects one at a time. Then when there was a bit of business coming in, then he decided to resign and like join the business with my mom, and that's when it started. My mom is the owner and still is to
Wow,
this day.
we love girls in position. So like you said, in this industry, it's mostly like moms and pops types
Yeah.
of workshops. That same thing went with my parents. Were Christian, so like in a biblical perspective, the Proverbs 31 woman was like that one. Most people think like, oh, she's supposed to stay at home and do the housewife things, but actually, she was a businesswoman, and it's really great when you see living proof of it working out, especially like how things are
Yeah, I mean,
going
husband
now.
and wife at the end of the day should work together towards a
Similar goal.
similar goal.
Right. So this is a technical question. On a conventional gasoline engine, the air in the fuel mixture goes inside the combustion chamber, and then a spark initiates the ignition process. So how is this different from a diesel engine
Basically, the diesel engine, there's no air fuel
mixture?
mixture in the sense that it's a mix of air and fuel going in the engine. So it's always just 100% air.
Mhm.
Then the fuel is regulated by the injection pump in old mechanical diesels, or in modern diesels, it's controlled by the injector actuation, which controls fuel quantity. So a diesel engine will always run lean. Even in full load, it should run lean, because once you get the rich mixture, that's when you get black smoke, and that's where you get the pollutants and increased heat, which is not good for the engine. So in that respect, the diesel engine is more efficient, but then again, compared to a gas where it's spark ignition, diesel is compression ignition, which means as you compress air, the temperature increases, and that's when the diesel fuel injects, which sparks the diesel. So there's no spark at all happening. It's just compression
the way-
ignition.
Yes. What happens when the injection pump isn't properly calibrated?
Two things can happen. If the injection pump isn't properly calibrated, well, one thing for sure is you will have performance problems. You will not reach the correct power or correct amount of smoke that the engine was designed to, the correct combustion that the engine was designed to perform. So usually when you have an injection pump or a fuel injection system problem, you'll get either stalling or black smoke or lack of power or hard starting. Like, these are the most common problems that you see.
issues.
Yeah, that's what we see in the modern diesels. It's practically the same. The only difference is there are now more sensors and actuators that govern the system, but it's still the same function in the sense that a fuel system is basically the system that takes the fuel out of your gas tank and into your engine. So
Okay.
when something goes wrong there, then you will feel something wrong with the performance of the car.
And that's when they bring it to you.
Yeah.
What are the repercussions of fuel consumption and emissions to the environment?
Well, at the end of the day, like, emissions really is down to nature and protecting our Earth. Like, we only have one Earth. If it dies, we die with it. Like, there's no going
Oh, well.
around about it. So
Yeah.
that's why we're seeing a lot of move towards electrification, which is
Yes.
EV hybrids, and then the diesel and gasoline systems are also going up in terms of their emission standards. So that's where you see the EGR system is introduced. From the wastegate turbos, it's now VGT turbos, and then you see started at around Euro 2, Euro 3, the catalytic converter. Then you have this newer catalytic converter called the diesel particulate filter. Then you have the one with AdBlue. So all of these systems are added to the diesel engine so that the emissions become less.
Yeah.
So yeah, I think with the advancement of technology, it's really our job. Like, keep your diesels calibrated, because that's the only way that you can actually help the environment and make sure that your car or truck is performing at the correct level.
So you said that the diesel engine is more leaner when it comes to running, am I
Yes.
correct? So gasoline, the ratio is 13 to 1,
Yeah.
and then for diesel, it's 18 to 1. Can you expand more on those ratios and the importance? And
So
what it
basically,
does?
people think that diesels are matipid, diba? They're economical to run, because the simplest reason is, for a gasoline engine, you have 13 parts of air to 1 part of fuel.
Yes.
So for the exact same displacement, exact same size of engine, you can actually use less fuel running it. Because in diesels, you're gonna run it at 18 to around 22, 23 to 1. So in that respect, you're using less fuel to run
Diesel.
a diesel than a gasoline. The downside of it is, with a leaner mixture, you get higher NOx, which is nitrous oxide, which is a pollutant. But that's why we introduced exhaust gas recirculation, so that you can introduce exhaust in the intake, so that you actually have less air during idle, so that you have less emissions. That's the real design of EGRs. It's not for power or anything. It's really for better emissions.
Oh wow. That's interesting. So when people want to make that new system, are you usually the ones doing it, or do they come to consult with you before doing that?
We are a diesel repair shop, so we don't design the systems. They are pre-designed in the cars. But
Pre-designed.
when these fail, they bring it to us so that we can repair it. Because, for example, when an EGR fails, it usually pushes the engine running a rich mixture, hence the black smoke. But yeah, the original design of an EGR is to make sure it runs less lean, so that it also has less NOx for emissions. So this is where the oil seal is.
Yeah.
So this shouldn't happen. There should be no oil coming out of the pump. So the problem with this pump is we will not be able to test it, because these are the test steps that we should take. We can't run it at speed because it might suffer failure on the test bench. So the nice thing that we mounted on this test bench is we can now see the problem very early on, and this you will not see in the vehicle. But if you don't check your oil, it can destroy your engine due to the fuel going into your oil, which will lose its lubrication properties for the bearings of the engine. So it's good that we're able to see it early on, and we can now address the problem and repair it. So this one is a similar pump to yours. Basically, what's happening is, in your pump, this one is worn. This is the shaft. And either the oil seal is worn or the shaft is worn. Most of the time, it's the oil seal and the bushing. So what we have to do is dismantle your pump to this, inspect every part, and give you a quotation of the parts that we think need replacement or don't pass the standards that are required for it to perform for a good amount of time. So this is an example of what's gonna happen to your pump down the line. So we're gonna pull it down from that bench, then we're gonna clean it out, externally clean it, dismantle it, inspect each part, then give you a rough quotation. We'll send it to you when you say you approve of our quote. Then assemble it, calibrate it, and give it to you.
All right, Jason. So we were able to see a while ago when you run the test bench, immediately the fuel comes out,
Yeah.
and that oil is going to the crankcase,
Yeah.
mixing with the oil of the engine, so it can get damaged. Now, I see a while ago you were saying the injector goes straight to the combustion chamber.
Yeah.
So the pump has to produce a very big amount of pressure, isn't
Yes.
it? What pressure are we looking at?
The
A
pressure.
high RPM, let's say.
At high RPM, I'm not really sure because you have an opening pressure for your injectors. So there's only a limited amount that your pump can produce
Mhm.
because the injectors will open and relieve the pressure.
Yeah. So the injectors more or less, like I have an idea.
For your specific engine, I would assume it's around 120 to 150 bar.
120 bar.
Yes, and that's still very low because the modern diesels can now go to 2,200 bar.
2,200 bar.
Basically, to explain, 2,200 bar is getting, I think, how many? 15 elephants standing on a square inch. So that's how much
Wow.
pressure that the current diesels are producing.
Imagine the amount of pressure that the pump has to go through it, and then that one's every day and everything. By the way, that injection pump that we have in here that we brought to you is close to 300,000 kilometers already.
So yeah, the wear is reasonable for 300,000. Like, we normally see it, but I think that would also fix your problem of stuttering at high load.
Regular fuel injector vehicle, gasoline engine, the pressure that we are looking at in the fuel rail is about 2 to 3 bar.
Yes,
This one we are looking about at 120 bar.
yes,
And then the modern CRDIs, we are talking about 2,000.
yes.
Amazing.
Well,
So these injectors are scheduled to be fixed. So they're now dismantled and we will be rebuilding them. So that's one injector, 2, 3, 4, 5, 6, 7, 8, 8, 16, 32 injectors for trucks. This one controls the timing. So as this lengthens, it changes the timing. As it shortens, it changes the time. So that's the old way of adjusting timing for this specific injector. Then for the new ones, it's just a change of time when the computer will trigger it. Now, this one is installed in a Starex, I think. Now this one is mounted there. Electronic actuation, you have a return measurement, and you have a fuel delivery measurement. This one is running right now, just supply pressure of 10 bar. We're gonna run it at maximum power. The data says that at this part number, which is shown up here, 9873, is there. At maximum power, your fuel delivery should be 48 to 59. When you run it, it's gonna run at 1,800 bar. That's the current delivery. So, if at maximum fuel, you are required to run at 48 to 59, and your injectors are performing only at 35 cc, your complaint will be lack of power. For us to fix that, we have to open the injector, replace parts, and then adjust so that we can reach the correct fuel quantity. Now, a lot of people are thinking, why replace parts? Why not just adjust? We've tried it, it doesn't work. When the parts are worn down, you really need to change. And then when you change, sometimes, of course, due to machining irregularities, you cannot put it in that bracket, then now you adjust. But this is how we test common rail injectors. Fuel quantity of the injector. Okay. So basically, on an engine, it's being triggered at 800 microseconds at full load. That is what the test equipment is trying to replicate. And at 800, it should have 48 to 59 cc. So this one only has 38.9, which is very low. That's almost 20% less fuel. Anything in the mounting, no adjustment. When you choose idle, it will have less fuel output, and the pressure requirement is lower at 325. It should be at 4.8 to 10.2. I think this should pass because this engine works well. Yeah. So this will run fine at idle. So for example, the customer comes in and tells us the engine won't run. Then we test this. We will tell him your injectors failed, but it will not come from your injectors, your complaint of not running. Because if there is no fuel at idle, then maybe. But with this one, this will run, but the complaint will be no power. So that's a basic 2-step test just to show you how it works. Idle and maximum power. So this is our garage. This is where we fix the vehicles that are brought in. Some customers just bring in the injectors or the pumps. Some customers don't have mechanics to remove those parts, so they bring in the vehicles here, and we're the ones who remove it and install it. And we also check it with our diagnostic tools to check if the problem is really in the fuel system or maybe in the other electronic controls of the engine. So that's what these all are.
So you say you check on the vehicles with scanners. Will you show us what scanners?
So we at Central Diesel use these scanners, and we also sell them. We are the distributors for FCAR F7SG, and we have one E81V upstairs, then the Think Tool Master. So these scanners are good for 12 and 24 volts. The nice thing about these scanners are they're not just code readers, so you just don't plug it in and get the code and remove it. You actually are able to interrogate the sensors, do actuation tests on the engine using these scanners. These are what you call bidirectional scanners. So it doesn't only receive data, it also can send data to do some things in the engine for testing purposes. These are all available here in Central Diesel. And if you want to have your vehicle scanned, we also have that service.
Alright, so this concludes the video for our trip to Central Diesel. Any last words for the audience?
I hope you enjoyed seeing what happens behind the scenes. Please feel free to bring your cars, your components such as injectors and pumps. If you're a guy who owns a car, or you're a guy who owns a shop who needs our specialties, needs a scanner, needs something scanned, give us a call, give us an email, add us in Facebook, Central Diesel Philippines. Send me a chat, I'll be the one to reply. Then, as we always say in Central Diesel for the past 20 years, cleaner air to our care. Bye.
Bye.
Central Diesel, cleaner air to our care.